Okay, sorry, my computer is acting up. Give me a minute. Okay, I don't know why it's not working. I'll quit the meeting and I'll rejoin, yeah? Just give me a minute, sorry.
لا إله إلا الله الخلق تثني.
قاعدين خرقة عاد سيف.
انتهينا. أول مرة تحضر.
Okay, hello again. Sorry about that. I had a problem and I had to reboot my computer. Hopefully, now we are able to actually continue. Okay, so at the end of the previous lecture, we spoke about uniform circular motion. and that is motion along a circular path, which goes on at a constant rate. And we said that the velocity is always tangential, but the direction, the speed is constant, but the direction is always moving, which means the velocity is always changing, which means, according to our definition, that acceleration is the rate of change of velocity itself, okay, that we always are accelerating, and we call that centripetal acceleration. And we said that acceleration is always towards the center, and that centripetal in Latin means seeking the center. And that our angle between our velocity and acceleration is always at 90 degrees. So how do we calculate this centripetal acceleration? The magnitude of the centripetal acceleration is equal to v squared over r. Now, I have a question. How many people here, when you were kids, played with I don't even know how to explain it. Nope, not that.
مقلاع دكتور مقلاع.
One of these مقلاع. لكن ما نتكلم عن هذا النوع اللي نسحب ويروح. نتكلم عن النوع اللي لازم نلفه فوق راسنا وبعدين ندوره فوق راسنا وبعدين يطش. Okay, how many people here played with something like this? Okay, yep, there we go. Quite a few people. Okay, now, if you remember, okay, maybe you didn't play with this, but you, at some point in our childhood, we were bored, and in one way or another, we decided to take a rope or a piece of string or something, and then just start rotating above our head, okay, like a cowboy lasso. كيف في الافلام ذاك الكاوبوي يوم يجيب الحبل ويها فوق راسه يلفه يدوره وبعدين يعقه. And then at some point we have done something like that in our childhood. Okay, now if you remember, okay, doing that, you will remember two things that you figured out without any physics. You just figured it out after a few tries, because basically what happened is في يوم من الأيام كنت تلعب بهذا الشيء أو كنت تلعبين بهذا الشيء و your speed or your velocity wasn't high enough, and that thing ended up hitting your head instead of continuing going in a circle. And then you probably, you know, swore and cursed at it for a good 5 minutes, and then you just went back to doing it again. But this time, you were like, okay, عشان ما يضرب راسي أنا بطول الحبل. But something happened. لما طولنا الحبل وقمنا نلفه احتجنا نعمل مجهود زيادة علشان نلفه بنفس السرعة. احتجنا نعمل مجهود زيادة، احتجنا نحركه بطريقة أكثر علشان أو بسرعة أعلى علشان يظله في دائرة. Then we probably got tired. وقلنا أوكي خلنا نقصر الحبل مرة ثانية. واكتشفنا أنه لما الحبل قصير الدوران يكون واجد أسرع. قصدي واجد أسهل. أنه أنا ممكن أخليه في دائرة بمجهود أقل وبطريقة أسهل بدال الحبل الطويل. Now, we knew these kind of things before we do any physics. Okay, we just tried it out and figured it out, which is, well, you know, experimentation, what we call experimental physics. Now the question is, ايش هذا الشيء اللي نحن كنا جالسين نسويه؟ What is the physical principle behind it? Why is it انه الحبل الطويل اصعب من الحبل القصير؟ وليش اذا السرعه ما كانت كافيه طاح البتاع على راسي؟ Well, it has to do with this. A equals v squared over r. This is the centripetal acceleration. Now you will notice that the radius of the circle is in the bottom and the velocity is at the top, which means if you want the same amount of acceleration to keep it in a circle, you need to do one of two things. You either need to increase your velocity, so you need to spin it faster, or you need to make your radius, i.e. your rope, smaller, shorter, to be able to get the same acceleration. And hence, all these times your toy would end up banging on your head. Now you know the physics behind it, okay? Either your radius was too big or your velocity was too small, okay? Now, I really hate the fact that I'm unable to see the screen chat. Let me try and open it on my phone. I only have a few percentage points on my phone for the charge, but nevertheless, I want to be able to see the chat. Okay. Here we go. Okay, now I can see your chat even when we are in the full screen mode. Okay. Now, let's take a look at this. This thing is going in a revolution, in a circle. What is the time it takes to go one circle, one revolution? If I have something moving, how do I calculate time?
Stopwatch.
Okay, timer. But if I want to a relationship between two things, what kind of relationship?
Distance over velocity.
Okay.
Distance and velocity.
Distance over velocity, right?
Yes.
Okay. What is my distance for a circle?
2 pi r.
2 pi r, my circumference. So my time to go one circle is 2 pi r over v. What happens if I do 1 over t?
V over 2
V
pi r.
over 2 pi r.
So if I do 1 over t, which is v over 2 pi r, what is this quantity called? Do you remember?
Frequency.
Revolution.
Frequency. Good job. So our t is what we call a time period, the time it takes for one circle, and 1 over t is frequency. It is how many rounds do we do in 1 second. Okay. All right. So let's see. If I have a steel ball which is tied to the end of a chain, I have not activated any PIQs. We're just doing this verbally. If I have a steel ball that is tied to the end of a chain, and the ball goes in a circle of radius r with a constant period t. Now I reduce the radius to 0.75 r, so 75% of what it was, but the period remains the same. What happens to the centripetal acceleration of the ball?
Increases.
Increases, okay. Any other answers? Anyone who disagrees with increases, thinks it decreases or it stays the same? Okay, Amr says it increases as well. Mariam says decreases.
Decreases.
Zahra says stays.
Doesn't change.
Okay, someone else says doesn't change. Well, let's see. We said t equals 2 pi r over v, صح? And we say t is fixed. So, if this becomes 2 pi, 0.75 r, and it needs to stay the same, what needs to happen to v?
Doesn't change.
V also needs to reduce by 0.75, right?
Right.
Okay. Now let's see. We said acceleration is equal to v squared over r. Acceleration before over acceleration after. Acceleration before was v squared over r. Acceleration after is 0.75 v squared over 0.75 r. صحيح؟ Let's simplify. 0.75 r v squared على 0.75 square v square r. v square يروح مع v square, r يروح مع r, 0.75 يروح مع 1, 0.75. So we end up a before over a after is equal to 1 over 0.75, which means that a after is equal to 0.75 times a before. So our centripetal acceleration actually reduces to 75%. Now we have a relationship. Yeah. We have our acceleration is v squared over r. And we have another one is our time period is 2 pi r over v. Now, why does it reduce? It decreases because we have put in a condition in the problem. We said the period remains the same. Because we said period remains the same, it means my velocity also increased. Otherwise, what happens if I reduce my what happens if I reduce my radius but keep my velocity?
Acceleration increases.
My time period increases, right? I am going through through a smaller distance with the same velocity. So my time period decreases. I need less time to complete one circle. But because I have set the rule that the period has to remain constant, it means my velocity also decreased. And hence, my acceleration also decreased. So far, so good?
Yes, Doctor.
Okay. This doesn't work, so I'll move to a different this. Okay. Let's look at a different concept. let's say I am in outer space. أنا فاضي عطال بطال ما عندي شغلة ولا مشغلة في الحياة، طلعت شوية أشرب لي كوب شاي في الأوتر سبيس. I see two spacecraft, an alien spacecraft and a human spacecraft. And as I look at them, they move this way. The alien spacecraft moves slowly, the human spacecraft moves fast. Good? أحتاجكم تصحصحون معاي لأنه أنا ما أعرف إذا أنتم your cameras are off, so I don't know if you are understanding or not. I don't have any visual feedback. Okay. لأنني أنا إنسان فضولي وكوب الشاي مالي خلص، دخلت داخل السفينة الفضائية، فيني فضول أشوف هي من داخل كيف. And here's what I see. Now what do you notice? Can you tell me? What do you notice?
Another spaceship moving across.
Okay. Is there anything different about it? So I'll play the previous clip first. Look at this. Look at the speed at which the spacecraft moves. And now look at its speed here.
Speed decrease?
It's as if the speed decreased, صح?
Yes.
Slow down.
Okay. It's as if it's slower. And it's as if I am not moving. Now, the reason I am doing this experiment in space is because I don't want to be biased by, other things moving on Earth. Okay. How many times, or if ever, have you been sitting in your car عند إشارة مرور وسرحتوا شوية وجالسين نشوف من الدريشة وفجأة أشوف السيارة اللي جنبي تتحرك وأبدأ أفكر هل نحن تحركنا قدام ولا السيارة اللي جنبي جالسة ترجع ريوس؟ Has this ever happened to you before?
Yes.
أو مثلا على الشارع السريع تسوق على 120 وفجأة يجي لك راعي اللكزس ويخطف عليك وتحس نفسك كأنك أنت واقف ما تتحرك. أيوة هي ال 430 ال 430. إنزين ما جاك الموت يا تارك الصلاة. إنزين هذيك أنت تجي تبدأ تتشهد على طول لين ما تطلع من طريقها. إنزين أوكي. أحيانا نحن على الشارع السريع طيب ويصير معنا كذاك صح؟ أنا والسيارة اللي جنبي نتحرك بنفس السرعة بالضبط ما تفرق. Exactly the same speed. What would I see from my window? I would just see this. My computer is not stuck, neither is your computer. I will see as if the other spaceship is not moving. Or if we are in cars ونحن اثنيناتنا جالسين حاطين كروز كنترول على 120 على الشارع السريع واثنيناتنا بالضبط جنب بعض طيب وانا اشوف من الدريشه بحس كانه السياره اللي جنبي ما تتحرك ولا انا اتحرك because we're exactly going at the same speed in the same direction the same velocity, right?
Yes.
زين. Okay. What about this? هذا اللكزس جات لكم. اوكي. راعي اللكزس ايش يشوفك؟ اللي جالس داخل اللكزس ايش بيشوفك؟ كيف بيشوف سيارتك؟
ترجع ريوس.
بيشوفك كأنك انت ترجع ريوس صح؟
Yes.
تراك انت بطيء ف انت بتحس كانك انت بالنسبه اللي راعي اللكزس انت جالس ترجع ريوس. too slow. Now these three cases انزين these three cases provide us with something very, very important. Okay. Measures of position and velocity depend on something we call a reference frame of the measure. And then, how is the observer moving? And on what we call a reference frame, and usually we use a ground. What do I mean by this? أنا طولي 160 سنتيمتر 164 سنتيمتر. بالنسبة لوالدي أنا برج، أنا طويل، بابا طويل. انزين الحين بخبرك احمد. انزين انت بنفسك بتعرفها الحين بعد ثانيتين. بالنسبه لوالدي اذا سالت والدي كم طول بابا يقول بابا طويل. لكن لو سالت ولد عمي اللي هو ما شاء الله نخله بيقول لك يحيى قصير. اوكي what's the difference? When my son says I am tall, he is looking at me from his point of view, from his frame of reference. To him, I am tall. When my cousin speaks about it, okay, he's looking at it from his point of reference. To him, I am short. Okay, so ممكن نسميها مرجع قصوري، ممكن نسميها وجهة نظر أو something like that. Okay, إنزين. But the point is أنه we choose something to compare stuff to, and we always do that. Okay, with whatever we do. دائما عندنا شيء نقارن فيه حتى لو نحن ما منتبهين. زين يكون عندنا نوع من انواع الاطار المرجعي نرجع له ونقارن الاشياء فيه حتى لو نحن ما منتبهين، بحكم التربيه، بحكم العادات، بحكم الثقافات، بحكم الاشياء. طيب نبدا يعني نبدا نقارن باشياء زين يعني تصير اللي هي بشكل طبيعي، بشكل ذاتي، ما اني افكر فيها. اتذكر لما انا رحت لندن شفت شباب في المسجد لابسين سلسله. استغربت. انا اعرف انه هذا يعتبر عندنا في الدين الاسلامي تشبه بالنساء، فما يجوز. لكن واضح انه هذا الشخص ايضا شخص ملتزم، ترى جاي يصلي في المسجد. والصلاة في المسجد في بريطانيا أصعب من الصلاة في المسجد في عمان. يعني احنا عندنا في عمان معروف أنه هذا وقت الصلاة، فأنت تاخذ بريك وتروح تصلي. هناك ما عندك هذا الشيء، لأنك أنت تطلع من الدوام وتاخذ بريك علشان تروح، هي سالفة تعتبر يعني something is weird. زين طبعا قبل ما أكمل السالفة، زين أنا ما جالس أفتي هنا، ولا جالس أعطي فتوى دينية، ولا جالس أعلق على أشياء فقهية. زين أنا جالس أشبه بمثال للأطر المرجعية. طيب أو لطريقة أنه نحن كيف الثقافة أو العادات أحيانا تخلينا نقارن بأشياء. سألت الشخص هذاك بعد فترة، صاحبته يعني كنت أشوفه كل يوم وهذا، وصاحبته قلت له يا أخي أبغى أسألك سؤال، ليش تلبس هذا الشيء؟ هذا تشبه بالنساء. قال لي من قال لك يا أخي تشبه بالنساء؟ نحن كلنا نلبس هنا في بريطانيا عادي، السالفة ما فيها شيء. مع مرور الوقت أنا فهمت، طيب هو الإطار المرجعي ماله مختلف عن الإطار المرجعي مالي. أنا لما أقول أنه السلسلة تشبه بالنساء أنا أشوفها اللي هي من وجهة نظر بيئية شرقية عمانية خليجية، هو يشوفها من وجهة نظر أجنبية. طيب الحين فقهيا هل هذا يعتبر حلال أو حرام؟ أنا ما أدخل في هذا السالفة، أنا ما لي دخل فيها. كل واحد يرجع للمرجع اللي هو يعتبره في الإطارات الفقهية. بس my point is أنه بدون تفكير أنا فورا رحت إلى مقارنة في مخي. طيب what is our usual frame of reference? The easiest one usually is the ground, because according to us the ground doesn't move. So when I say السيارة تمشي على 120 أو اللكزس تسوق على 220 مقارنة بإيش؟ مقارنة بالأرض أو بالشارع اللي هو ما يتحرك بالنسبة لي. صحيح؟ طيب سؤال، لما أنا أقول أنه ارتفاع جبل إيفرست 7.7 كيلو، أو لما أقول أنه الطيارة هذه تطير على ارتفاع 30,000 قدم، إيش الإطار المرجعي مالي؟ What is my reference of my reference frame? Where is my point 000?
Sea level.
Sea level. Which sea level? البحار والمحيطات على ارتفاعات مختلفة. Turns out at some point people met واختاروا ارتفاع بحر معين وسموه سي ليفل، وكله الحين نحن هذا نعتبر هذاك سي ليفل. فنفترض مثلا انه السي ليفل خل اعطيكم مثال عملي. السي ليفل في بريطانيا مثلا نقول هنا، السي ليفل في عمان ممكن يكون شويه مرتفع. السي ليفل في البحر الميت هو اخفض نقطه على الكره الارضيه من ناحيه البحار، اللي هو هنا في الاردن. لكن whenever we talk about heights we always take sea level معين اللي هو agreed on sea level. ما اعرف وينه صراحه بالضبط. طيب أنا I like to confuse you, so I will do something here. I have 3 coordinate systems here. Is there any difference between them?
I think no.
The position.
Position, direction, what else?
0 point.
Okay. 0 point. Let me ask you something. The alien ship is moving at 10 meters per second. The yes, Hafel? The human ship moves at 5 meters per second. Now, if I am standing on the outside, I got another cup of tea, ورجعت أشرب شاي. I will see the alien ship moving at 10 meters per second and the human ship moving at 5 meters per second. طيب لو أنا جالس داخل الالين شيب at what speed am I moving؟ إيش بحس؟
0.
0 صح؟
Yes.
طيب إذا أنا جالس داخل الهيومن شيب بالنسبة لي أنا السبيد مالي 0 والالين شيب تخطف علي، أنا أشوف الالين شيب تمشي على كم؟
5 meters per second.
5 meters per second
5
اللي هو
meters.
الفرق ما بين السرعتين. صحيح؟
Yes.
Okay. Now we're going to do a few applications on this idea، ولكن نقطة ننبه عليها قبل ما نعدي. طيب this treatment اللي نحن نسويه في هذا الكورس ما ينطبق على النظرية النسبية العامة والنظرية النسبية الخاصة مال أينشتاين. أنا أعرف أنه كثير من الطلاب يجون الفيزياء وهم حلم حياتهم أنهم يتعلمون النظرية النسبية أو يفهمونها. Unfortunately that's quite difficult. النظرية النسبية الخاصة نبدأ نشوفها في Physics 3 والعامة هو بالعادة كورس واحدة. طيب ولكن راح أعطيكم overview إن شاء الله عنه في الشابتر عن gravitation chapter 13 لاحقا. But the point is أنه whatever treatment نحن نسوي هنا أننا نحن نجمع السرعات ونطرح السرعات works very well for all speeds accessible to humans. This is called Galilean Relativity. Okay. And I'll explain to you in a second what this means. It stops working when we approach the speed of light. When we come to a high enough speed that I can give it a certain percentage of speed of light, then it becomes problematic. What's the fastest thing you can imagine moving on Earth other than light? أسرع شيء ممكن يتحرك.
Fire bullet.
Bullet, okay. شيء ثاني. حد
الصوت.
يقدر يفكر شيء؟
الجيت.
الصوت، اوكي. بعد غير لايت. ريان وفاطمة غير لايت. Okay, someone said something? Train, okay. Sound, okay. Quite a few people are saying sound. Let's do a rather quick comparison. A car is usually around 120 kilometers per hour. A train is usually, give or take, about 220 kilometers per hour. A plane is closer to 270 kilometers per hour. Okay. Sound is 330 meters per second, which in kilometers per hour is actually 330 times 3600 divided by 1000, about 1188 kilometers per hour. No, that doesn't sound right. 330 divided by 1000 times 3600. Yeah. Okay. Bullets are usually faster than this. So bullet, okay. So this is what we call, this 1188 is what we call Mach 1. Okay, speed of sound is Mach 1. Bullet is usually 1 to 1.5 Mach. Then you have the F-16, for example. Okay, it usually goes up to 3 Mach. And the if I am not mistaken, one of the fastest things to ever move was the SR-71 Blackbird spy plane, which could go up to about 12 Mach. Okay, as far as Earth is concerned. Okay, I am going to go for something even higher. So plane 270 kilo, plane, sorry, not plan. Okay. Now I am going to go from my head, and I am going to say something around 50 times the speed of sound. Good? That is what? That is 50 times 1188 equals that is 59,400 kilometers per hour. C, the speed of light, is 3 times 10 to the power 8, which is 1, 2, 3, 4, oops. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so which is this many meters per second, which in kilometers per hour is even worse. So 3x.
2 مليون.
كم كيلو في الساعة الضوء؟ This is kilometers per second, and this is in 1 hour, 1,080,000,000 kilometers per hour. 1,080,000,000 kilometers per hour, which means that if I want to see as a percentage 50 Mach or Mach 50 is barely, okay, how much? 59,400 divided by 0.006%. So it's very, very low. Okay. So Galilean relativity, what we do, is good enough for pretty much everything we do on a day-to-day life. Okay. Yeah, in physics research, once protons and electrons are go into super colliders and all that kind of stuff and becomes very, very fast, أمور تتغير, we need to take relativity into consideration. But for most things, this works. Okay. Okay. Now, Ahmed, if they can break through the sound barrier, it simply means that it can travel faster than sound. Okay, so when I said, for example, the F-16 moves at 3 Mach, for example, it means that it moves at 3 times the speed of sound. So it's actually really cool if you see it in live, because what happens is you see the airplane move, and then, you know, about 3 seconds later, you hear, if it's Mach 3, then 3 seconds later, you hear the sound of the airplane. Okay, نفس البرق والرعد. نشوف البرق وبعد عدة ثواني نشوف الرعد. نسمع الرعد. It's the same idea. Okay, breaking through the sound barrier just means إنه it can go faster than sound. ما أعتقد حد فيكم لحق على الكونكورد. في حد فيكم لحق على الكونكورد؟ ركب الكونكورد أو سامع فيها؟ طيارة الكونكورد؟
لا دكتور.
سامعين فيها لكن ما حد ركب فيها.
زين، انا راكب الكونكورد مره واحده في حياتي. زين, this is what it looks like. Okay, and it was a civilian airplane. Okay, not a warplane. It was a civilian airplane which would go at faster than the speed of sound. It could go twice the speed of sound, actually 2.04 Mach. Okay, Mach 2.04. So it could go twice the speed of sound. Okay, so it was really, really cool. Okay, and being on the inside was actually a really, really nice experience. So you would be sitting in the airplane, and there would be this, what you call it? There would be this panel that shows you the current speed. And then it would go 0.8, 0.85, 0.9, max 0.9. Then everyone gets excited. And as soon as you go to 1, yeah, the plane shakes quite violently, and you hear like a pop on the inside. On the outside, you hear an explosion. On the inside, you just hear a pop. Okay, because the sound actually happens after you have passed. You're going through faster than the speed of sound, which was very, very cool. Okay. Anyhow. All right. Let's say I have 2 cars, VA and VB. رجعنا خلص الكوب الشاي مالي وما حد سوى لي كوب إضافي فرجعنا الكرة الأرضية. عندنا سيارتين. We have VA and VB. سيارة A with velocity A, سيارة B with velocity B. Okay. I'll make them look cool. One of them will be yellow. One of them will be red. Okay, the red one looks like a Supra, and the yellow one ما أعرف شكلها كأنها RAV4. Okay. Now, I say VAG equals 10 meters per second, and VBG equals 10 meters per second. What does AG mean?
To the ground?
With respect to the ground. So when I say AG, I am saying velocity of A with respect to ground. Velocity of B with respect to ground. Now, what would VBA be? The velocity of B with respect to A. So if I am
Zero.
sitting inside A, what would I see the velocity of B be?
0 meters per second.
0.
0. صح? We're both going at the same speed. Okay. What about VAB? If I'm sitting inside B, what do I see the velocity of A?
Zero.
Again, 0. Right? So far, so good? بس يا أخي it's not fair. BM وفراري يكونوا نفس السرعة. It's not fair. Race on. Now VAG is 10 meters per second, but VBG is 20 meters per second. Now what is VBA? If I'm sitting inside car A, what do I measure the velocity of B to be?
Ten meters per second.
10 meters per second. Right? The difference. Okay. What if I'm sitting inside car B? What do I measure?
Minus 10.
minus 10.
Minus 10.
Excellent. Minus 10. It's just like when we're looking at the spacecraft and the other spacecraft. It will look as if the yellow car is actually going in reverse. And the distance between them will increase continuously. Excellent. Let's see. Do we want to do some PIQs or do we want to continue? Okay, do you want to do some PIQs or do you want to do some, do you want us to continue?
أنا think دكتور.
PIQs.
PIQs, do you find them useful?
Yes, they are good.
يلا بسم الله. خلينا نروح week 5 PIQs chapter 4 section 4.6. بتشوفوا ثلاثة 4.5 4.6 5.1. بنروح على 4.6.
أوكي دكتور.
اوكي. صار في هنا إشكالية. هذا شكلهم مال الصبح بعدهم ما مسكرين. And question. Close. اليوم الموديل يقرر انه يدلع.
كان عويق قبل كم يوم.
ما زال عويق. ما زال عويق. انا يطردني كل شويه ويطردني شويه ويطردني.
دكتور يعني شيء كويز هذا الأسبوع؟
الشيء ان شاء الله. حتى الان ما حد اشتكى انه الريدنج كويز يسوي اشكاليات، فراح نحاول نعمله لانه في مصلحتكم انه يكون في more points because it's easier for you to get marks. اذا لا سمح الله شفنا انه السيرفر طاح او شيء بعدين نلغيه، بس for the time being let's do it و let's see.
أفضلنا صحيح هو.
نفس الوقت بيكون دكتور؟
نفس الوقت كل اسبوع كل اسبوعين في نفس الوقت ما يتغير.
الخميس يعني؟
الاربعاء ما الخميس.
4 ساعة كم؟ 6؟
7:30 كان. Okay. Cars A and B are moving away from each other. Car A moves north at 25 meters per second. Car B moves south at 15 meters per second. What is the velocity of A with respect to B? So if I'm sitting inside B, what do I see the velocity of A? Sorry, you were saying something?
ما ظهر معنا دكتور.
اعمل ريفرش
سوينا.
وتأكد انت على 4.6.
ايوه مسوي 4.6.
ايش يطلع؟
ظهر دكتور ظهر.
موجود
ظهر؟
موجود.
ظلك تسوي ريفرش شويه شويه، احيانا شويه يشكل او الريست تايمر. اوكي Okay, let's see. How did it go? "59 students said car A is moving due north at 40 meters per second. 42 students said car A is moving north at 10 meters per second. So let's see. If my car A is going up, if my car A is going up at 25 north, and car B is going down at 15. When I am sitting inside car B, what do I see car A moving at? Well, car A is moving north. It's not moving south, no matter what I do. So this cannot be right. This cannot be right. Okay. Now I am going 15 meters per second south. So my velocity of car A from the inside of car B will be equal to 25 minus 15 because it's in the opposite direction. It becomes 40 meters per second north. Yeah?
Again, Doctor, please.
So your car A is going up at 25, your car B is going down at 15. If I am sitting in car B, what do I see the speed of car A being? Car A is already going at 25 meters per second up, and I am going 15 meters per second down away from it. So in total, for each second that passes, car A will be 40 meters per second further north than I am. Let's look at it this way. We have two cars, okay? Each one of them has their own axes. Car yellow is frame A, car red is frame B. Now, let's do an even more complicated problem. Okay, we have a police car. Now, okay, let's say I have a yellow car, a red car, and a police car. Now we have velocity of car yellow, car A, we have velocity of car B, and we have the velocity of car P, which is the police car. Now that we have a distance xBA from car A to car B, and xPB from car B to car police, right? What is the full distance from car A to the police car? The distance is simply the sum of the two distances. XPA is equal to XBA plus XPB.
Yes.
Yeah, so far so good. Simple enough?
Yeah.
Yeah.
Okay. So positions in different frames are related by a simple sum. As far as the velocities are not near the speed of light. Okay, simple enough. If I want to use this equation to find what is the relationship of velocities, can I do that?
Yes.
What do I need to do?
XBA equal VBA over TBA.
Okay. So everything divided by t, or I can simply take the derivative, right?
Yes.
And I will get VPA equals VPB plus VBA. So far, so good. Now, what happens if I take that and I want to find the acceleration?
Divide.
By
T.
By T. By T.
okay. I will get this, right? I will get APA equals APB plus ABA. Sahih?
Yes.
Okay, but this makes it very, very complicated because it means our reference frames are actually accelerating. Yeah, so our frames of reference are moving away while our velocities are also moving. Okay, so to go back to this, okay, it will mean that by the time car yellow is here, okay, car red will be here, but also this will now be here. It will no longer be here. And this makes the problem very, very difficult. Okay, so what we do is, for the time being, we are going to take only non-accelerating frames of reference. Okay, so what we're going to do is, we're going to set VB, the acceleration of VAB, okay, for the acceleration between any two between any two reference frames to be 0. So my acceleration of any external observer of anyone not relating to cars A or B will be the same for both of them. I know this is confusing, so let's do this. Okay. Let's do this. I have the velocity of BA. This is not a PIQ. I don't know why this is here. This should be on a separate slide. This should be here. Okay. So I have the velocity of car B with reference to car A. So if I'm inside car A, I'm looking at car B and I'm seeing a velocity of 52 kilometers per hour. I'm still in car A and I'm looking at the police vehicle and it is coming at me with a velocity of 78 kilometers per hour. So I put a negative because it's in the opposite direction. What is the velocity of car B? Sorry, what is the velocity of the police car if I am inside car B? If I'm inside car A, the velocity of my police car is minus 78 kilometers per hour. But what is the velocity of the police car if I am inside car B? How do I do this? I simply rearrange this equation. I have VPA equals VBA plus VPB. So VPB will be equal to VPA minus VBA. VPA is minus 78, minus VBA is minus 52, which tells me that my total will be, what is 78 plus 52? 130 kilometers per hour.
Minus.
Okay, with a minus sign. وضحت الفكرة؟
Yes.
Okay. Let's do a PIQ. Now this PIQ has two parts. We have part A and we have part B. Now initially we are only going to do part A. Okay, here we go. Question is live. Cars A and B are moving east as shown in figure below. Police car is moving west. Velocity of police car with respect to A is minus 78. B with respect to A is 52. What is the velocity of car P with respect to B? Velocity of PB. This is what we just did now. So let's see if you are awake to remember. Okay. Let's see how many people were awake for part A. Police car B is moving west at 130 kilometers per hour. That is excellent. We have a stuck system. Okay. 88 people chose the correct answer, 130 kilometers per hour to the west. 3, 3, 2, 1, 1. So 2 and 2 is 4, and 3 is 7, and 3 is 10. 10 people were asleep because we just did this in the previous slide, and we calculated it to be minus 130. Okay. Now let's do part B, which is the more important one. If police car P brakes and stops relative to car A in time 10 seconds, what is the acceleration of P relative to A? 5.2 meters per second square, 2.2 meters per second square, 7.8 meters per second square, or simply 0. And I'll give you a few minutes for this. Okay, most people are still doing the question. Okay, let's see what we got. We have an overwhelming number of students who chose 2.2 meters per second. which is excellent. So, according to our rule, VPA is equal to VPAI plus AT. This is our rule اللي هو من بداية V equals U plus AT. صحيح? We need to find A. My final velocity is 0. My initial velocity was 78 kilometers per hour plus A. And my T is 10 seconds, which means my A is equal to 7.8 kilometers per hour per second. Now I have done something very, very stupid because I did not convert from the beginning, which is something that I tell you to always, always, always do, which now makes me look like an idiot. So let's do that. 78 kilometers per hour is how many meters per second? Times 1,000 divided by 3,600. That's 21.7 meters per second plus A 10, which means A is equal to 2.2 meters per second. Well done to everyone who did this question correctly. Very well done. Okay. It's 1:20. We are done with chapter 4. Inshallah, beginning of next lecture, we are going to start chapter 5. But before we end this lecture, I want to actually have a verbal survey about the tutorial. So section 31 here has already undergone. Actually, let me stop the recording first because I don't